Hello, my name is Faisal Subhan and I'm the admissions tutor for the School of Biomedical Sciences at the University of Plymouth. I'll be giving an overview about the programs we run in our school, and just to mention, I'm also a lecturer here in biomedical science, specifically in human physiology. And I'll be using my Prezi presentation today to cover some of the things which we teach and what we do in our school here in Plymouth. So what we do offer are distinct degree courses at our school, and I'll be talking about those different courses. You should be seeing an image right now of some of our faculty members. So right at the top, there's a picture of Chris Jeremy, who's our program lead for Biomedical Sciences, and this is one of our largest programs. On Chris's right-hand side, we've got Andy Foey, who's program lead for Human Biosciences, another degree program. And then below Andy, we have Lynn McCallum, who is program lead for Clinical Physiology, which previously used to be called Healthcare Sciences, Physiological Sciences. Next to Lynn, we've got Gail Rees, who is also our head of school and is program lead for Nutrition, Exercise and Health. My image is there as well, being the admissions tutor. And above me is Nicola King, who is our program lead for the foundation year. Now, I'll be talking very briefly about some of these programs right now, and later on I'll be talking a bit more in detail about some of the programs. Now, just to mention here at this moment, we have got a separate presentation by Andy Foey for applicants interested in human biosciences, and we can make that available to applicants. We've also got a separate presentation for Nutrition, Exercise and Health, which has been given by Gail, and again we can make that available to applicants as well. Biomedical Sciences is one of our most popular programs in our school, and this is a program which normally has about 100 students, and I believe last year we had an intake of maybe about 110 to 115. It's an accredited program, and it's accredited by the Institute of Biomedical Sciences, the IBMS. It's one of the largest in the Faculty of Health, in which we sit in right now, and it's got a very high student satisfaction. Human Biosciences is another program in our school. It's distinct and it's got its own characteristics, and it's distinct from Biomedical Sciences. It is a smaller cohort. It is a cohort of about 30 students every year, and the aim on this program is to get students to understand how humans function at the molecular, cellular, physiological, but also psychological levels as well. So one thing you'll see on this program is that they are possibly more options and more optional modules on this program. And apart from the biological and science modules, we also have optional psychology modules, and there's a psychology strand running throughout the 3 years. So there's an option to take a psychological module in year 1, year 2, and in year 3. And obviously these modules cover the biological, but also social and ethical issues as well in science. Healthcare Science, Life Sciences was a program we used to run. Because of funding being removed by Health England, we've turned this into a 4-year program. So students will basically do the biomedical science degree program, and then between years 2 and 4, they will do a 1-year clinical placement in the NHS, which our university will organize. And this is for students who are sure that they want to enter an area into clinical laboratory diagnostics, where life scientists will be providing diagnostic information on blood and tissue samples. There are 3 routes normally which we teach at our university. There's a route for blood science, for example, that covers hematology and things like anemias and leukemias. There's an area of cellular science, which covers pathology, for example, histopathology, which covers like the staging and grading of cancers. And then there's infection science as well, which looks at immunology, bacteria, viruses, macrophages, and immunoglobulins and other immune cells in our body and immune function. So that's if someone's decided to have a career in the NHS. We've got a very similar program to the applied biomedical sciences, which is clinical physiology. So this is also a 4-year route. And like the applied biomedical sciences, there's a 1-year mandatory requirement to do an NHS placement, again, between years 2 and 4. Now, unlike the applied biomedical sciences, which looks at obviously, tissues and samples and cells from the human body, the clinical physiology looks at clinical testing of patients. And there's 2 routes on here. There's a cardiovascular route and there's a respiratory sleep route as well. This program is very patient orientated for students during the placement and also when they graduate. And I'll talk about these 2 different routes, the cardiovascular and the respiratory, later on. We also have a Bachelor of Science for Nutrition, Exercise and Health, which is for 3 years. And this is for students who are interested in exercise and also the nutritional scientists. Students can benefit from accreditation by the Association for Nutrition, which also allows our graduates to have a direct entry onto the register of associate nutritionists. Students on this program, I believe, during year 2, also have an option to earn a YMCA Level 3 Personal Training Award. And most of the students do that. And I believe the expenses for that are also covered by the university for that award. We have a Biomedical Science Foundation year, and this is suitable for students who may be mature students and returning to study, or it could be for students who've done a BTEC or A-levels or an IB and didn't do science in their qualifications. Or it's possible some students did do science, but they didn't meet the requirements. Students who complete this stage, when we normally call this stage 0, then they can enter into stage 1 or year 1 of any of our programs from our school. So they can complete the foundation year, and after the foundation year, they can move on to biomedical science, human biosciences, clinical physiology, applied biomedical science, or nutrition, exercise, and health. Students are expected to obtain 60% on this. And the benefit of doing the foundation year with us is that you're taught by teachers who will teach you in your first, second, and third year. So myself and many of my colleagues, we teach on this first year, on this foundation year. And also the students will benefit from getting used to, for example, living in the city, getting used to using our digital learning environment tools, and the way academics teach and the way they get assessed as well. And some of the modules on this biomedical science foundation year are co-taught with students who are doing a foundation year in medicine and also who are doing a foundation year in dental therapy and hygiene. And we normally have a capacity for about 30 to 40 students every year. So that was a brief overview of what we offer. I'm going to now talk about why study at the University of Plymouth. So obviously our most important asset is our staff. Almost all of our staff are fellows of the Higher Education Academy, which means they've got a postgraduate qualification in teaching, apart from having a PhD. And I also didn't introduce our head of school, Dr. Gail Rees, who's also program lead for nutrition, exercise and health. Dr. Chris Jeremy is our deputy head of school, and he is program lead for biomedical scientist. So Gail is a nutritionist by training and profession, and Chris is a biochemist by training and profession. We believe all our staff are friendly and supportive. You can ask our student ambassadors. We've got a thriving research community and postgraduate school, which I'll talk about later. We've also got very close links with the medical and dental schools and other schools in the Faculty of Health. Students are allocated a personal tutor in their first year with us, and they will also be their personal tutor for the complete duration of that degree program, whether it's a 3-year program or a 4-year program. We believe we've got modern and well-equipped laboratory facilities. This is an image of some of our facilities. Just recently, in October 2018, we opened a new laboratory which can hold 110 students. And these are some images of the laboratory. This is in the Davy building. And it has a glass partition here, so the laboratory could be split into 2 classes of about 50 to 60 students, which can run simultaneously, and the glass partition won't allow any noise to enter into the other side of the laboratory. So you could have 2 different classes going on that at the same time, if need be, or if the need is, that partition can be removed, and we could have a large class inside there of 100 students. There's obviously audiovisual equipment, and it's a state-of-the-art laboratory, and this is used for undergraduate teaching. Apart from that, the university also officially opened the Derriford Research Facility, which our school runs, and this was done at the cost of about £17 million. It's close to the main hospital in Plymouth, and it's adjacent to the John Bull building, which is the building housing the School of Medicine and Dentistry. I have a little video here which I will show you, and this will be a virtual tour of the Derriford Research Facility. I'd just like to add here that if you go to any of the websites of any of our program web pages, for example, Human Biosciences or Nutrition, Exercise and Health, if you just scroll down on that web page, you'll find a link for facilities, and there'll be the ability to take a virtual tour of several different facilities on our campus. So again, you'll have the ability to see the Derriford Research Facility and some still shots of that. You'll have the ability to see the nutrition unit as well in the Link building. You'll have the ability to see the Human Performance Laboratory and Exercise Laboratory in Smeaton building, the Clinical Physiology Laboratory in Portland Square, and some other generalized areas as well, and lecture halls. So please do that and have a look at that. So that's what the building looks like. And it was opened by the Princess Royal, Princess Anne, in 2018. And I've got this video to play. So that's the first floor of the Derriford Research Facility. And you can probably tell from the laboratories that there's a lot of different specialized laboratories. This is a general area, but there are specified different laboratories there. There's an area for confocal microscopy, for specialist physiology, and of course molecular biology and microbiology. There's some, different kind of laboratories in that building. This is a generalized area which a lot of research students use. We don't do any undergraduate teaching in here for obvious reasons. It's a few miles away from campus. It's a 20-minute bus ride away. But students at the end of their first year and at the end of the second year can apply for a competitive paid bursary to do research at the Derriford Research Facility and to do research in several different types of areas. And students can also do their final year project here as well. And imaged over here is right at the front there is Tracy wearing the laboratory coat, and Tracy Madgett's one of our lecturers in biomedical science, and she spends most of her time at the Derriford Research Facility, but she's also involved in teaching. And that's the first floor of the building. There is of course a ground floor for the building as well. We've been awarded the Silver Teaching Excellence Framework from the government, and we believe that our courses will train graduates to have transferable skills and lab-based problem-solving skills as well. A lot of our content is very current, and every faculty member in our school is involved in research. So often that teaching is research-led from current developments all around the world, or possibly also from research from our own researchers and their laboratories. Students are encouraged to contribute to our research output. I'll be talking about this later on. And the university's recently climbed up a few places in the Guardian League tables and now is on 60th position. There's just one of our students getting an award at an international conference for some work she presented a few years ago. We believe there's a lot of support around in the university, and the university has just recently opened a hub covering well-being and support for students in the main library, and there is advice for health there. There's support for mental health as well. There's 24-hour support for mental health online. There's support for international students. There's support for careers and employability, and there's support about disabilities as well there. So it's all under one hub now. It was just recently opened a few months ago in the main library. Apart from this, what our school also does is get our students involved in what's called PALS, or peer assisted learning. And this is something where our more senior students, for example, the second years and the third years, they help our more junior students in the first and second year. So it's a good opportunity for our senior students. They get paid to do this, but again, it's a good experience for them, and they help guide and give our students a kind of non-threatening environment. Although we kind of think we lecturers aren't really threatening, but we still give that opportunity for students. If they are, not sure, they don't want to ask us a question, they can ask students in senior years about different things, about the theory of the courses, about assessments as well. So we run this on a regular interval as well, and on a regular basis. And it's basically run by the students, for the students. We believe we're in a beautiful part of the United Kingdom. Obviously, very close to us, we've got Plymouth Hoe. We've got lovely beaches just a few miles away from the university campus. And of course, just north of the city, just a couple of miles out of the city, we've got national parks as well and areas of outstanding beauty. Now I'm going to go into a bit more detail about our courses specifically, and I'll start with biomedical sciences. So this is, again, learning about how the body functions and learning about the diagnostics and therapeutics and what happens when things go wrong in the body. And this is for students who want to follow a biomedical science career. I mentioned already it has IBMS accreditation, which is very useful if someone wants to work in the NHS as a biomedical scientist. In terms of careers, students can go into basic and clinical research. Some of our students have got jobs in the Plymouth Science Park. There was one student, a graduate and an MSc student, was working with a firm which was basically a spin-out company from the university, BioVault, which was looking at stem cells from newborn babies. Students can work in as an academic, they can go into industry, they can go into laboratory diagnostics with private companies, and also they can work in the NHS or other laboratories like Public Health England. This is just some data from the government about where our students are and what are they doing after 6 months. And 90% of them were either in further study or working after 6 months. This is an example of one of our graduates who completed his biomedical science degree and is now working in a microbiology laboratory in transport immunology as part of an organ retrieval team. And James is working as a medical technical officer in Oxford. Moving on to one of our other programs, Human Biosciences. So it's short for Biomolecular Sciences, and this covers how humans function at the molecular, cellular, physiological, and psychological levels. It obviously has research-informed teaching, and this program has, because it's not accredited, it allows a lot more flexibility on this program. So students can have a wider selection of modules. For example, in year 3, they can have a neuroscience module. They can have a reproductive science module, which I'm heavily involved in, where we get clinicians to come from the IVF clinic, from the hospital, and teach our students about problems with in vitro fertilization. And as I mentioned before, Human Biosciences also allows the options of having psychology module in your first and second and third year, and that's optional. Some data we have is that about 20% of our graduates from Human Biosciences go into medicine or dentistry. About 20% of them go into further study with an MSc or PhD. About 10% of them go for further accreditation. 20% of them get involved in teaching, about 10% in industry, and another 20% use their transferable skills in a wide range of different careers. And 90 to 95% of our students on this program are in employment or further study within 6 months. And there's just a photo of one of our graduates a couple of years ago who got an award for one of her essays in London. And this student, I believe now, is studying medicine at Plymouth University. Probably near to finishing it right now. Georgia is one of our graduates. She's a surgical sales specialist working with a global women's healthcare company. So that's just, again, one of our alumni. I didn't mention this previously, but you can go onto our web pages for our different programs, and every program web page will have some kind of alumni stories and possibly some videos and some more information about, where our graduates and alumni are going to and what are they doing. So that gives you an idea of what kind of fields you can go to when you graduate and what's open. Clinical physiology, as I mentioned before, this was called Healthcare Sciences, Physiological Sciences. It's accredited by the National School of Healthcare Sciences and the Registration Council for Clinical Physiologists. This is a 4-year program. As I mentioned previously, there's a 1-year placement between years 2 and 4. It covers cardiac physiology. So again, very patient facing. So a student who would be working in this area may be seeing 10, 20 patients a day. And likewise, the same in respiratory, seeing several patients every day. And in respiratory, sleep also going on to wards and doing some testing there for patients. Again, the cardiac graduates may be also going to accident emergency using defibrillators. So they are trained to be experts on ECG, working in cath labs with cardiologists, doing ambulatory blood pressure monitoring, and helping with echo as well. And the respiratory sleep, they're obviously doing lung function testing for patients with lung disease, and also doing various different types of tests on the lung. They're also doing testing for sleep apnea for patients who may have sleeping problems when they, or rather breathing problems when they sleep. This is a very important part of the NHS because the majority of clinical diagnoses depends on diagnosticians giving them the results. And again, it's looking at how the human body works in altered health states and wanting to have a job which is very patient facing. These are the placements. So for the applied biomedical sciences and the clinical physiology, these are between years 2 and 4. Students can do these placements in the Southwest. We've got very good contacts with biomedical scientists in life sciences and in clinical physiology all across the Southwest and even beyond. And some of our students now are also doing their placements in London, Southampton, Bath, and even Birmingham, and possibly even Manchester. So it's possible to do them very close to home, that year 3 placement, and that will be organized by us. This is just an example of Ben, who graduated 6 years ago, and Ben is now a senior clinical respiratory and sleep physiologist at Churchill Hospital in Oxford. And I believe you can get more information about Ben and other graduates and alumni on our web pages. With the applied biomedical sciences route and the clinical physiology route, graduates can enter into the NHS at a band 5 level. They are different training programs which graduates can do afterwards. There is a scientist training program, an STP program, which is like a taught master's program, which is funded by the NHS, and graduates can even go on to the higher specialist scientific training program and do a PhD in the NHS. So there's lots of career options within the NHS, and there's a lot of chance for progression in the NHS, so much so that they can also reach a position of a consultant in the hospital as a consultant scientist. Just some data here. The life science course, so it's now the applied biomedical science course, 90% of these students were in a professional or managerial job at 6 months. And for the clinical physiology, it was 100%. And often you'll see students signing even a contract before they even graduate, because there's a shortage of biomedical scientists and physiologists in the NHS. So from our 2019 cohort of clinical physiologists, and it's a small cohort because it's limited by the number of placements, we have only 10 or 15 students graduating every year. So last year, for our clinical physiology students, 3 of them took up positions at Derriford Hospital, our local hospital in Plymouth. 2 of them in cardiac, at the cardiac clinic, and 1 of them in the chest clinic with the respiratory and sleep team. This is just what a typical timetable looks like for our students. This is their modules for year 1. So although this is for biomedical science, many other students on different programs will have a similar kind of structure anyway. All our graduates, all our students in the first year will go through biomedical investigation and experimentation for the first 4 weeks, and then they'll have that done and dusted in 4 weeks, and then they'll go into an anatomy and physiology program module, and they'll also have a biochemistry and human metabolism module. They'll have their Christmas break, have their exams, they'll come back and start an introduction to human pathology, and then after that, a month later, they'll start human disease and pathology and infection and immunity after that. And there's also a study skills and personal development module, which is 0 credit rating, but basically is a pass-fail module, which means they have to pass that to move on to the second year. So other programs have slight modifications. For example, clinical physiology, they won't have the human metabolism and the infection immunity module. They'll have cardiorespiratory physiology and cardiorespiratory pathophysiology in place of those 2 modules. So these are large class formats often. Students will be in a hall of possibly 200 students. But as students progress into the second year, the cohort size for these lectures will get smaller, sometimes 50, sometimes 20 students per lecture. That's just a typical timetable I've taken randomly from about 2 years ago, again showing that it's a full-time study and students could have lectures, workshops, practicals, tutorials randomly placed throughout the timetable. Wednesday afternoons are generally given to sports and other activities. And again, it's a full-time course of study, and for every contact hour with faculty and with teaching staff, students are expected to study for 3 hours along with that 1 hour of contact. Students can also transfer onto medicine or dentistry after the first year if they fulfill some specific academic requirements. And this changes on a regular basis. But for example, hypothetically, if the entrance requirement for medicine was AAB next year, and if a student obtained that this year, they could then apply for this transfer. Of course, they have to clear an interview, and they'll have to have a DBS check and also occupational health screening. Some students join us and then they've got very good grades and they decide to transfer after 1 year. Some students may have their A-levels remarked. Sometimes we've had students who have changed their mind and decided that they don't want to study biomedical science and they may want to study medicine. So we do lose 1 or 2 students to medicine or dentistry every year through this pathway. We're sad to lose these students, but again, it's a student's choice. But this pathway is available, and it's an optional pathway for biomedical science and human biosciences students. Again, there's also a possibility that student wanted to do medicine but couldn't find a place that year. Then they'll come onto this program and then they can try for the year after. Now, we obviously are involved in research as well, and our faculty was ranked first in the UK for research outputs in medicine. 80% of the research was graded as world leading or international quality. The school has obtained grants from various granting bodies, including the Royal Society, from the EU, from the Medical Research Council, the Wellcome Trust, Marie Curie Foundation, and many, many other granting bodies. This is just an example of some of the money, and there are some themes for research in our school. For example, disease and diagnostics. So money has been granted to look into the genomics of cardiovascular disease. We have a branch or a theme for infection and immunity. And there are large grants which have been given for vaccine development. And also there have been grants looking into research into new antibiotics. There's also a cancer theme as well, and large grants have been put into the faculty for looking at brain tumors. And this is just some images of some of our colleagues. Professor Matt Upton, one of our colleagues who's a microbiologist, and he's made a spin-off company looking at new antibiotics. Dr. Michael Jarvis has also made a spin-out company looking at new vaccines. So he's currently also involved in developing a new vaccine for COVID-19, the coronavirus, and he's working with colleagues in China and in the United States. And he's worked also previously on other types of virus vaccines, for example, Ebola virus. Professor Simon Jackson has left to run his own company, a spin-off company from the university. But again, he's still got very, very close links with the university. And Simon developed products which can be used for water testing. For example, looking at bacterial cell counts in a beach. So previously, what would happen was Public Health England would take a sample of beach water, send it to a laboratory, and several days later, if the count was very high, they would decide to close that beach because it was unsafe for public use. Simon's developed a new test where literally in minutes and in hours, a test can be done there and then on the beach and decide whether that beach is safe for public use or not. And of course, it could be unsafe because there could be high levels of bacteria in the water, and that could be dangerous for the public. But the benefit of that is obviously that people can find out very quickly, because previously people could be using that beach without knowing that it's harmful, and it could cause a lot of disease and difficulty to a lot of people. So that's just one of the aspects of Simon's research. We actively get our students involved in research. So we've mentioned the opportunity for first and second years to do a bursary, a summer bursary with us. And we've also had students who've got external funding from that, from different academic societies. We've also had students to do who'd opted to do a placement year within the university. So these are some publications where I think all the students are actually first authors on these research papers. And there are many, many research papers which were published with students. And there's a picture there of some of the students who work with one of my colleagues, Andy Foey, to work on a very well-received review on probiotics in the immune system. And we've also had students present data at meetings, at prestigious international meetings, and present oral presentations and present poster presentations as well. And we actively encourage our students to do that, because that's a part of the learning process. So, what do we expect after this? Well, after 3 years or possibly 4 years, if a student's doing a degree with a placement, we expect students to be here. But again, we'll be there to support students. Students can also do a research master's, the ResM, or a Master of Philosophy, or a Doctorate of Philosophy, a PhD in our school. Students can also do a MSc in Biomedical Science at the university in our school. Students can also go on to an MSc Physician's Associate Studies at the School of Medicine, which requires a life science undergraduate degree. And that's something which is obviously in working in the NHS as a physician's associate. Some of our students like to enter into medicine or dentistry after graduation, and if a student is predicted a first class, then they can have an interview, and if they clear that interview and if they get that first class degree, they can go into studying medicine or dentistry. So there's a graduate entry option as well. And for this, the graduate entry medical examination is not required, the GAMSAT, and that's waived for 2 years. So I've also seen myself students who have graduated with a degree, gone out and worked. I've seen some students work in the NHS for 2 years, probably earn some money and save some money, and then come back after 2 years and join as a medical student. Again, not requiring the GAMSAT. Lastly, but not least, as I mentioned, we have a hub for careers and employability. It's in the library now. We also have placements and employability modules throughout the 3 years of a student studying with us. We've got specific software to help our students, to help develop their curriculum vitae, their CVs, to let them look at some mock interviews, and to give them some help on going down that path of going into work. So I hope you enjoy our virtual talk today. Please go and look at the virtual online tours of the facilities and the laboratories. If you wish to email me or contact me, I'm happy to take any questions. Feel free to contact and email our program leads. And I will mention again that there is a separate talk given by Gail Rees for nutrition, exercise and health. If you require that, please contact us. And there's also a separate talk for human biosciences. All right. Thank you very much. Have a great day.